Okay, so let's look at finding average rate of change. And another way to think about average rate of change that you might be familiar with is the slope of a line between 2 points. And that's basically what we're finding with average rate of change. Okay, so we're given a graph and asked to ultimately find the average rate of change, but first we want to find the change in the x values, all right, the values going from left to right in an interval. And this interval always refers to x values. When we talk about an interval of values and we have both an option of y values and x values, most of the time that language of interval is talking about x values. So we want to find the change in x as x goes from 1 to 4. Okay, that probably makes it sound way more complicated than it is. To find that change, we're just going to take the difference. And so 4 minus 1 is 3. That's the difference in those two values of x, and that's the change in x as it goes from 1 to 4. Okay, now we want to go and find the change in y values. So that's the up and down, the vertical values, for that same interval as x goes from 1 to 4. Okay, so we have to actually figure out what those y values are. So if we go to the graph and we find where x is equal to 1, right? It's going to be right there. We go up to the graph. Well, here is the point where x is equal to 1. And we can identify that point as the x value of 1, comma, the y value of 3. Okay, so there's one of the y values, the one that goes with the value 1. And the change, then we go to x equaling 4. And so here's that point, right? So for x is 4, y is 0. Okay, so we want the change in y on that interval. Okay, well, we always take, we go in the same order that we did for x. So we took the larger minus the smaller for x's. So we are going to take the y value that goes with 4, which is 0, and subtract the x value that goes with 1, which is 3. Okay, so we get negative 3. All right, so now the average rate of change over that interval, 1 to 4, is equal to, in words, the change in y over the change in x. Okay, so you can see it's exactly how you would define slope. And so we just found those changes. The change in y is negative 3. The change in x is a positive 3. So the average rate of change over that interval, 1 to 4, is equal to negative 1. Okay, so then the other thing that we can look at here is if we were to draw a line between those 2 points, a straight line, it would have a slope of negative 1. And we can see that it's decreasing. And if we work that slope out, we see that for every 1, it goes down, it goes to the right one, down 1, right 1, down 1, right 1, which is exactly what that negative 1 would tell us. All right, now let's look at when we don't have the graph of a function, but we actually have the function in a formula or equation form, and we want to determine the rate of change, the average rate of change over the interval. This time the interval is 1 to 7. Okay, so I want to write down how we find it when we have the function in this notation. So instead of y here, we're going to swap in this f of x notation. So we're still going to have the change in the vertical distance, but now we're going to represent that as the function value for when x is 7 minus the function value for when x is 1. All right, so f of 7 would be the y value when x is 1, as x is 7, and f of 1 would be the y value when x is 1. and then we put that over the change in x. Okay, so to finish that off, we have to determine what f of 7 and f of 1 are. So if we plug in f of 7, we get 49 minus 42 plus 8. All right, and that gives us a value of 15. All right, 7 plus 8, so we get 15. And then f of 1, 1 minus 6 plus 8, and we get 3. So plugging those into the average rate of change, we have 15 minus 3 over 7 minus 1. So we get 12 over 6, which is 2. Okay, so again, if we were to think of these as points, which we would have gotten the point 7, 15 and the point 1, 3. Okay, the line going through those 2 points would have a slope of positive 2. All right, it would be increasing and it would go up 2 and to the right 1.